Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 23 on our 2016 Cayley contest. Suppose that PQRSTUVW is a regular octagon. And then they go on to explain what a regular octagon is, in case you don't remember. There are 70 ways in which 4 of the sides can be chosen at random. That's true. 70 happens to be 8 choose 4. If you know binomial notation, you'll know this. But you don't really need to know binomial notation for math contests, so we can ignore that. But it is true that there are 70 ways to do something like that, to choose 4 sides out of 8. If 4 of its sides are chosen at random, and each of these sides is extended infinitely in both directions, what is the probability that they will meet to form a quadrilateral that contains the octagon? Let's sort of explore what they mean. Let's draw an octagon here. Oh, that would be a hexagon I'm starting to draw. I wonder how this question would be different if it was a hexagon. Okay, so let's, pick 4 sides at random. This one here. And so they're saying extend in all directions. And I guess we do have a quadrilateral. And the hexagon is inside it. Now, just to make sure I really understand what's going on in the question, can I at least find one way to make this not happen? I definitely want to experiment, but let's go back to the question. So, I think I understand what they mean by quadrilateral contains the octagon. We just want the probability. So they're telling us the 70 because we want our probabilities to be out of 70, like C. Although some of these are out of 35 in case it was 38 over 70, or over here 34 out of 70. So we're definitely going to figure out some number over 70 and, if possible, simplify it. Okay. So, well, I think there's probably going to be a fair bit of symmetry in what we've got going on. Like, the 70 ways to do this are not all unique. So one thing we could maybe try to do is look at the different possibilities. I mean, here's one, but of course that's also the same as if I sort of rotated everything. I mean, you're just going to get your picture rotated, but they are counting these as different quadrilaterals here. So maybe we could look at classes or sets of these things that do work. Now, the probabilities presented, none of them was 1, so there's got to be ways to make this not work. And maybe, I don't know, let's see if we can find a way to make it not work. Now, if I have 2 opposite sides here, no matter what else I choose, they should be able, they'll always extend, and this quadrilateral will enclose it. Unless, maybe if I choose them on the same side. Let's put that one there, and then maybe put this one here. And then, I'm not sure that these do enclose a quadrilateral. Maybe I need to draw a smaller picture here. So what did I have? I had 2 opposite sides, and then I guess 2 on the same side. not really seeing a quadrilateral that's enclosed here. Unless you technically want to say, maybe count this twisted quadrilateral. Either way, the hexagon is not enclosed by stuff here. So, okay, I guess that's what this is. It's a weird setup here. Now, do we want to explore this? Are there other ways to make it not work? Sometimes. So what we basically have to do is we have to either count the number of ways, the number of sort of patterns of chosen four sides produce a quadrilateral that contains the hexagon, or another thing we could do, because we know the total number of ways, 70, is we could find the number of ways that don't create a quadrilateral that contains the not hexagon, octagon, and then subtract that from the total of 70, and then put that number over 70. Because if you count the things you don't want and take that away from the total number of things there are, period, what'll be left? The stuff that you do want to count. And so it might be easier to find situations where it doesn't work, although admittedly they're looking kind of weird. Maybe it's easier to just completely look at each possible case. I don't know how many there are. There's 70 in total, but how many ways are there to break down the octagon? So I guess I'll always look at this one. I'll make sure that this is always highlighted, and I guess we could just highlight the next 4. So that would be a case, and there are 8 possible ways to do this. 8 choices of this first side. Okay. So that would contribute 8 things. Now, this scenario here would be a little different. Highlight those first 3, and then leave a bit of a gap. Okay, and there's 8 ways to do that, I would say. Okay, this is going to end up being really hard to count, isn't it? I suppose we could have this one opposite that, and there's 8 ways to choose to do that. Choose the pair that are opposite each other, 4 ways to do that, and then choose which one of them has the 2 sort of little wings coming off on the side. So there's 8 ways to do that. Okay. What else could we have? Now, I suppose we could have these 3 and then have this one, but isn't that sort of just going to be the mirror image of this scenario? So we'll update this one and say that it does 16. Once I figured out all the cases I need to worry about, and you know, I'm already up to 32, so that's almost halfway. So this doesn't seem like a complete waste of time. What could we have? Well, we could have that one that I know doesn't work. Have a gap in between them like that. And there's 8 ways to do that. 8 ways to pick this side, and then the 2 on either side work out. So now I've got 40 of these 70 cases. I guess the 70 is just to tell me when I don't have to keep looking for things anymore. Let's see, we could do that and that. Leave a gap. Leave another gap. Haven't done that. How many ways are there to do this? This looks like there might be 16 ways to do it. Pick this side, and then these 2 are flanking the opposite side, and then 2 ways to pick the adjacent one to this first thing you chose. So that's 16 possibilities. So there we're up to 56 different ways to pick sides on an octagon. Okay. I'm running out of things I think I could do. Could I have a gap between everything? Yeah, I suppose we could. And there's 2 ways to do this. Because either you pick this one or you pick one of these slanty ones. Yeah, you either have that or you have this blue one, but other than that, everything's sort of symmetric. So this gives you 2 cases, and incidentally, while we're at it, you can say that, oh yeah, it'll extend to a square, so there's 2 cases that definitely work. So what are we up to? 58. So we've got 12 more to go. Could have 2 together again and have a gap of 2 in between. And there's 4 ways to pick that. I'll pick one of these 4 blue dots, and that'll determine, and then the other side is determined by the opposite of your blue dot. So now I've got 8, so there's one other thing that's going to have like a symmetry of 8, I would suspect. And then we'll look at each of these cases. And we can't have a gap of 1 between everything. We do something like this, maybe? Have we done that already? No, we have not. It's similar to this, in that 2 things are separated, but these guys are separated by only 1 thing, whereas these ones are separated by 2. So that'll be my other case that has 8. Okay. So now I guess we can just sort of try to extend these out. I don't know whether or not to give... I'll do them on another page. Everything except that case that only had 2, because I already did the square there. We could try and go and... I'm going to actually give myself a bit more space, because the earlier pictures were getting kind of big. Okay, so let's try... I don't know, let's try this one here. So if I extend the sides... Yeah, we'll get a parallelogram, so that's 8 that work. Okay, oh, sorry, 4 that work. That's my mistake. Okay, so 4 work, 2 work, so we're at least 6 out of 70 cases work. So let's go back to our octagon. And what other cases were there? Well, there was... we already know that one of these that I drew doesn't work. So we'll put a pink no there. So 8 of them don't work, definitely. But what about this one here? So if I extend these sides... The quadrilateral that they all bound is this thing up here, which does not contain the octagon. So that's a hard no up here. So that's at least 16 that don't work. My octagon's getting a little sloppy, but I think we're still okay. Let's try the last one that I managed to cook up. So this one, and then there's a gap of 2 in between them. So that works out fine. So that one works. So we've got at least 14 out of 70. And at most 54 out of 70. Okay, let's try one of these 16s, I guess. So we can actually keep most of this the same. Instead, just highlight this one, and we're still going to be fine. So still good. So these last 4 are working. These 2 pink ones, not so much. Let's try the other 16, see where that takes us. So that's 3 that are on the same side. Or not all on the same side, but 3 of them that are together. And where's the other one? Just 1 off. Just 1 off. Now, these are opposite each other, so they're not actually going to intersect. So, where will my quadrilateral end up being? Is this another one of those sort of twisted ones? Yeah, I think the only thing that's bound by all of these is sort of this shape here. But it's not really a good quadrilateral, but no, we're definitely, I think it's at least clear to see that what the octagon is not contained in anything. So that case is out. It looks like if you've got sort of two opposite sides, and if these opposite sides cut things in half, or if you pick two opposite sides and cut things in half, and everything else is on one half, it looks like it's not working. Anyway, those 16 are out. What about this last set of 8? So 3 of them together and 1 diametrically opposite. So 1, 2, 3, 4, and yeah, we get this sort of nice little trapezoid shape, which contains it. And that's our last group. So there we go. So there's 4 plus 16 plus 8 plus 8 plus 2. Which is 38 that do work. We could also see that there's 32 that don't work. 32 and 38 is 70, so I haven't missed anything. I'm wondering if there is a way to sort of make an argument about dividing it in half and having everything on one side. Maybe with maybe the quadrilateral angles get too obtuse or something like that. If there is such a thing, if you've got a way to do it, I would love to read about it in the comments down below, or maybe Waterloo's solution has it. But I think breaking it down into cases has worked just fine for me. I don't think I took too long to work these out. And so it's been good, but if you got another way to do it, I always want to hear new ways to do it. And actually, if you, I'm saying this, I haven't finished the question yet, but if you wanted to generalize this, tell me, what do the probabilities look like for, if it's not an octagon, maybe a hexagon, a little smaller, or a, decagon or a dodecagon or 14gon. Does the probability increase as the thing gets bigger or decrease? I would suspect it probably, if there's this rule or this idea of if you pick two opposite sides and then sort of all the colored sides are off on the one side, including those two opposite sides, if everything's contained there, if that's a rule, I would suspect the probability might increase just because there's more sides that you could have on the same side. But I don't know. Somebody can very well investigate that and tell me down below. But I'm going to get back to the question to finish it off. So it's 38 out of 70. So we can divide top and bottom by 2, and we'll get 19 out of 35. So that's my probability, and is that one of the possible answers? It's B. So we're going to bubble in B. And that does question 23 quite nicely. I will see you for question number 24 in the following video. Until then, take care.